Okay, Honors Algebra 2. Today should be Wednesday the 15th, if I got my days correct. And yesterday we started looking at sequences or patterns of numbers. And today we're going to continue that by looking at a specific type of pattern called an arithmetic sequence. But I want to clarify one thing here. You do need to get that homework posted by the next day before I post my answer key. That way I know you're attempting it before you see my answers. And I'm not grading it for right or wrong. I'm going to give you participation points on that homework. So I want to post those keys so you can see. I want to post more than just the answers. I want to post my work so you can see the work done with it and you can check to see that you're doing things correct. All right, and I know in the video I said 7 a.m. I think I'll just make it 8:30 the next day. But I am trying to keep things short for you, especially the homework, so you can possibly watch a video, take the notes, do the homework, and get all that done, in 30 minutes. Way less time than what it would be if we were in school sitting in class, okay? So today, an arithmetic sequence, a specific type of sequence, or it is a specific type of sequence that simply you add or subtract a constant value as you work from one term to the other. Okay, so when we look at a sequence like the one I have here, first off, does everybody know what the dot, dot, dot means? That means it continues with the same pattern indefinitely. Okay, so anytime you see a dot, dot, dot in front or back, it just continues in that direction with whatever pattern is established. Well, what pattern is established in this one as we go from left to right? Do you see it? Well, we're adding 5, okay? In an arithmetic sequence, that's called a common difference. Now, the textbook way to find a common difference, and the reason why it's called a common difference means subtraction. If you look at your sequence, you can if you take any term and subtract the term in front, so 8 minus 3 gives you 5, 13 minus 8, 18 minus 13, 23 minus 8, it stays the same all the way across. You always get an answer of 5. That's why it's called a common difference. But we're going to take a little closer look at this pattern for this sequence and see if we can't understand what's the ins and outs of it here. All right. Now, yesterday with Mr. Patterson, you learned that each one of these numbers in our sequence is a term, and we denote that by the position that term is. So that 3 is in the first position, that 8 is in the second position, this 23 is in the fifth position. All right, now that's a key, understanding the position of your term. All right, now let's take a look and understand the relationship between the position and how many of these 5s we added, okay? So to go from 3 to 8, we added 1 5. Well, 8 is the second term, and notice how many 5s you added, 1. To go from the 8 to the 13, we would add 5 again. So to get to the third term, if we start at the first, how many 5s did we add? We added 2. To go from 13 to 18, we add 5 terms. So to get to the fourth position, if we start at 3, how many 5s do we add? 3. To get to the fifth position, if we started at 3, how many 5s would we add? 4. So what can we say about the number of 5s that we add? It's always 1 less than the position. Okay, so keep that in mind here. So that means if our position is in, we will always add in minus 1 of those 5s. All right. So keep that in mind here. Whatever position. So if I say something about what about the 43rd number in line? Well, one thing that you can tell me about the 43rd number in line right now is you would have added 5 42 times, because we always add 1 less 5 than the position of where we're going. All right. So let's look at this a little logically here. Think about giving directions. When you give directions somewhere, if somebody says, "How do I get to your house?" First thing you're going to ask is, "Where do you start at?" Okay. Well, we always start in our sequences with the first number in line. It's called the first term. All right, so let's say we wanted to know how to get to this 23. Say, how would you get to 23? Well, you have to start somewhere. You say you start at 8. Okay. Then you say, how do you move? Just like when you give directions, you say, go south on 15th Street, make a right on Main, go down to Main, make a left at Dairy Queen, what have you, and into that neighborhood. And my house is the third house on the right. So you give some kind of directions. Where our directions here are, you start adding 5. Okay. Well, by the time we get to 23, which is the 5th number in line, how many 5s would we have added? 5 minus 1 of them. We would add 5 minus 1 5s, or 4 5s. All right? Minor mistake here. You probably already caught it. First number in line is 3. We would have started at 3 and started adding 5s, and we would have added 4 5s. So we get 3 plus 20, we get our 23. Okay? So if we generalize that, and we say, how do we get to any number, any mystery number out here in our list, somewhere out here, any mystery number, 74th, whatever, any mystery number, so we'll call it A sub n. How do we get there? Well, we have to know where we start at. We always start at the first number. Then we have to know what we do. Well, we start adding whatever our common difference is. And in an arithmetic sequence, our common difference, the variable that represents it is a d. So we start adding some d's. How many do we add? N minus 1 of them. And this is the formula for an arithmetic sequence, okay, that we're going to work through today. So again, A sub 1 is your first number in line. D is what you're adding or subtracting. And N is how many times do you add or subtract. It says how many times. Okay. So let's take a look here at some problems. Okay. So we're going to use this formula, look to use this formula. And again, hit the wrong button here, so we'll get to that arrow in a second. So here's our formula. To get to any number in line, we start at the first number and we add n minus 1 of these d's. So let's say we want to find the 37th number in line. We know we're starting at 5 and we're subtracting 3. Now one thing you should be able to tell me is to get to the 37th number, we would subtract 3 36 times. And you can try to do that by hand, or you can just say, start to fill in these blanks or these variables on this formula. You say, well, the 37 number line, that's the position. So that's n. My first number in line is 5, and my common difference is 3. So if we fill all those in, we would find that the 37th number in line would be equal to 5 plus 37, or 37 minus 1 times a negative 3. Okay, which we simplify and we get that right there. So again, it's like directions. How do I get to the 37th number? Well, in this list, we started our first number 5. And if we're going to the 37th number, we're going to add 36 negative 3s. Now, I know this D might be more comfortable to put in front, but this is just the way it's written mathematically. And that's the formula you would see in a book. Okay, then you just simplify and you find out that your 37th number is negative 3. Now, another thing you can realize is if D is negative, then your list is getting smaller as it goes. So if we start at 5 and we start subtracting 3, eventually we get a negative number. So it makes sense that by the time we get to the 37th number, our answer is negative. Matter of fact, we subtract 3 twice and we'll be at negative 1. So it doesn't take long on this one. So keep that in mind when your D is negative, that eventually you'll get to a negative number if you're not already there already. Okay. Let's say we want to find the first number in our list. If we know the 30th number is 93, and we know what we're doing each time, this time we're adding 3. Okay. Now you want to realize that this piece of information right here is a twofer. We're getting 2 pieces of information at a time. We get a position of a number, it's the 30th number in line, and we get what the actual number is. So how would we fill in those 2 pieces of information into this formula? Well, we would say 30th number in line is our position, that's our n, and the actual number that's sitting out there is 93. Of course, we know our D is 3. So if we fill everything in, there's what we get. So again, we could say, how do we get to the 93rd number in line? Well, we start at the first number, which we don't know. We'll figure it out. And if we're going to the 30th number, we would start adding 3 29 times. Simplify this down, and we find out the first number in line was a 6. So we started at 6 and started adding 3, and 30 steps later, we're standing on 93. All right, how about finding our D value? Whoops, don't look at that. Okay, how about finding our D value? If we know our first number is negative 27 and our 18th number is 92, and remember this is good information to have here because it fills in 2 spots. So pretend you didn't see what just popped up, and why don't you fill in and create what the equation you're going to solve here, and I'll give you a little bit of time or hit pause and see what you come up with. Okay, did you get 92 equals negative 27 plus 18 minus 1D, or how do we get to this 92? We start at negative 27 because that's our first number, and we got to go out to the 18th number, so we will add 17 of our mystery D's. Well, now we can find all these, we can figure out this mystery D value here by just solving this, and we find out that what are we adding or are we subtracting? Well, we're adding 7. Now we could have made a determination all right off the bat. If the first number is negative and the 18th number is bigger than that, then what does our D value have to be? It has to be positive. So we can kind of use that as a little check. Okay, so that's the arithmetic sequence and 3 different example problems there, and you got a short homework on those 3 examples. Okay, and try to remember to get that posted. We'll say by 8:30 the next day before I post the answer key if you want full credit. All right, I will give you partial credit if you don't post it before then, as I need to see that you have got, that you are doing the work and how you're doing it. Again, it's not graded for right or wrong, it's graded for participation. Okay, so there we go. See you tomorrow.